So actually, this is the part of chapter 5 that's really nice because it recaps lots of chapter 10 as well from pure year 1. So I know people will have had a different relationship with chapter 10 depending on how much work they were able to do over the lockdown period. But we're going to be doing some equation solving here, and actually these are the rules that we need to know about, and these are the things that are going to help us of how to solve these equations. Now, with degrees, we knew that these formulae existed, and we came up with them in those earlier bits of the chapter. Apart from, instead of it being the sine of pi minus x, it was the sine of 180 minus x. Cos was with 360, and there was this really important feature that the solutions for sine and cos repeat every 2 pi, which means every 360 degrees, or tan repeats every 180 degrees. So as long as you know those ones, the radians ones you can just kind of translate into radians language. So I've said here, the only differences are going to be that your calculator is now going to need to be in radians mode, and we use pi instead of 180, and so on, okay? So this time we're being asked to solve this equation, sine theta equals 0.3, in the interval 0 and 2 pi, between 0 and 2 pi for theta. And what's interesting here is the question doesn't need to tell you that it's in radians. It is implied that it's in radians by the fact that it says it's between 0 and 2 pi. So can you all get your calculators out, please, and just make sure that your calculators are in radians mode. Do you know how to put it into radians mode? Have you got a calculator with you, Hannah? No. Okay. So, normally when you would solve this equation, to find out what theta is, you would do the inverse sine of 0.3. What's an alternative way I've written inverse sine before? Arc sine. So you could either write arc sine 0.3 or inverse sine 0.3. I don't know why. Sometimes I put brackets with inverse sine, but not with arc sine. I don't know why. I probably should do brackets with both or neither, but whatever. And so the calculator is going to give you the principal value, the first value that is. Motsin, what does it give you when you do inverse sine of 0.3 in radians?
It gives 0.304692654.
0.30. And was that the 3 significant figures, or should it be 0.305?
Right.
So I didn't say what I needed it to be, but this is going to be just to 3 significant figures, okay? So that's how we find the first solution. Now, when you go back to what the rules say here, to find a second solution, you will do pi minus the answer. And pi is literally just going to be the pi button in your calculator. So your second solution, you're going to find by doing pi minus whatever this answer is, your 0.30 blah, blah, blah. And that's going to give us the second solution. So can you, on your calculator, press pi minus that answer that we've got there? How much, sorry? 2.8369, blah, 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 like this. So if I was going to do this one to 3 significant figures, I would say 2.84. This is this not in the one you've got? It's in the one that you've got. It's in chapter 5. It just seems a bit different, but it's the same kind of thing. 2.84 radians, but I don't have to write the units or anything. So theta is 0.305 or 2.84. For some reason, I've decided to do them to 3 significant figures. Usually would say like 2 decimal places or 1 decimal place. And you'll notice that there are no other solutions that go inside this range. It's between 0 and 2 pi. And you should roughly think to yourself, 2 pi is about 6.2, 6.3. So there's no other solutions. The way that you could possibly find solutions, and I'm pointing this out to people who maybe didn't see this topic before, is because sine and cos repeat every 2 pi, you can add 2 pi to this, and it would still be a solution, but it would be bigger than 2 pi. So it wouldn't be inside the range. And you could add 2 pi to this, but it wouldn't be inside the range. So there's only going to be 2 solutions for this particular one that we've got here, okay? So those are our 2 solutions. The next equation that we've got looks a little bit different. So we've got 4 cos theta equals 2. We know it's radians, A, because we're doing radians, but B, because of the range that it's given us, the interval. What do I need to do first when I have that 4 cos theta is equal to 2? I have to divide by 4, and 2 divided by 4 is a half. And so now, theta is going to be the inverse cos of a half, but I don't want to use a calculator. because this is something you should know, what the inverse cos of a half is. Think what angle of cos gives a half?
5/3.
Pi over 3, it's 60. Okay, 60 degrees, so it's going to be pi over 3. You'll notice this time, because I can give it as an exact value, I am giving it as an exact value. Here it's a decimal, I can't do anything about that, but if you can give it as an exact value, you should and must give it as an exact value. Now, the second value is found for cosine by doing 2 pi minus the one that the calculator or that your brain gave you. Now, you can do this without a calculator, so you need to do 2 minus a third. What is 2 minus a third in thirds? 5 over 3. So it is 5 pi over 3. So this one here was found by doing 2 pi minus pi over 3, but you really do need to get good at doing this kind of thing in your head. 2 minus a third, I think of 6 thirds minus 1 third, which is 5 thirds. Obviously, you can do this on a calculator, but if you start now doing it without, your brain will get good at it. You will save time in the long run. It's going to feel slow for a while, but your brain will get better by having done it in that kind of way, okay? And those are the only two solutions because, like I said earlier, you could add 2 pi to either of them, but they're going to go outside the range of 2 pi, between 0 and 2 pi. So we can't do any more to that part of the equation, okay? Any questions on this? Because obviously this is possibly new for some people. Okay, we're going to do some other ones that we've got here. So we've got 5 tan theta plus 3 equals 1 in this interval here. Now, I think it's pretty obvious we're going to need to make tan theta the subject. So I have 5 tan theta plus 3 equals 1. First step is going to be to subtract 3, so I have minus 2. And I get 5 tan theta is equal to minus 2. So tan theta is minus 2/5. Then to find out what theta is, I'm going to do the inverse tan, or arc tan, means the same thing. This is one that tends to be a bit more like formal. This is one that's on your calculator. So I'm going to do the inverse tan of 2/5. And that's what we're going to get straight on our calculator, what the answer is for this one. And I'll have that to 2 decimal places, please, Hannah. Minus 0.38, okay? We've got 381. Like I said 2 decimal places, but that's fine. You just didn't hear me say that. So we've got minus 0.38. Now, what's the problem with minus 0.38 here?
It's outside of the range.
It's outside of the given range that they've actually asked for us to do. It's outside of the given range that we've got here. So this one is not going to be valid. This one is not going to be a valid solution that I actually want to give. What did I say that tan does, though? How often does tan repeat?
Every pi.
Good, every 180, but now it's going to be every pi. So I'm going to find the next one by just plussing 3.141. I'm plussing pi. So could you just tell me what that is to 2 decimal places when you add on pi?
2.76.
Pardon?
2.76.
2.76. Great, 2.76. And then we're going to add on another pi. 5.90. Now, I could add on another pi, but what would happen? It's going to go outside the range, so I'm not going to do any more. Now, I'm going to just put a line through this and say I don't want that as one of my solutions because it's outside of the range. But the calculator, I think this is true, the calculator gives you the value that is closest to 0. So that's why the calculator gave us minus 0.38, because it's the one that's closer to 0. 2.76, although it's positive, is further away from 0. So that's why that one is given here, okay? So this equation is a little bit different. Hannah, what's different in this equation that we've got? The difference is on the left-hand side. What? Good. It's a sine of 3 theta. In all of the previous questions, we've had the bit inside the function has just been theta, or I think x, maybe just theta. Does anybody remember from my videos before? What did I call this bit that goes inside? The bit that goes inside the sine or the cos. It's a weird word that you wouldn't expect to pop up in maths.
Argument.
Good, argument. So if I say argument, the argument basically means an input. So if I talk about the argument here, the argument is not theta. That's a bit different. The argument is 3 theta. And the way we do these questions is the range at the moment says that theta is between 0 and 2 pi. So my first step that I did previously here is I change the range. I change the range, so instead of it saying theta, I want it to say 3 theta. And to go from theta to 3 theta, I've multiplied by 3. So I'm going to multiply that by 3, and I'm going to multiply that by 3. So what I'm actually looking for is for my answers to be between 0 and 6 pi, and then you'll see what happens afterwards, okay? That's okay. So for this equation, I'm going to say that sine 3 theta is equal to root 3 over 2. So the argument is 3 theta. So 3 theta is going to be the inverse sine of root 3 over 2. However, you should know what the inverse sine of root 3 over 2 is. But I don't want it to be Sam who tells me. Do you know what the degrees are for root 3 over 2? Pardon? 60 degrees. Good, it's 60 degrees. Sine of 60 is root 3 over 2. So the inverse sine of root 3 over 2 is 60 degrees, which is pi over 3. Now, we need to find out our solutions all the way between 0 and 6 pi. For sine, the way that we find these solutions is by doing, good, it's usually 180 minus the answer on the calculator. So we're going to do pi minus this. So this one that we're going to find here is going to be pi minus pi over 3. You don't need a calculator for this, so what's the answer? 2 over 3 pi. It's like 1 minus a third is 2 over 3 pi. Now these are just two solutions, but the range is allowed to go all the way up to 6 pi. How do I find additional ones from these ones here?
Plus or minus 2 pi.
Good, you can plus or minus 2 pi here. So I'm going to just concentrate on this one to begin with, which I'm going to do in one colour. I'm going to say this one here. I'm going to add 2 pi to it, and I'm going to keep adding 2 pi to it until I get above 6 pi. So when I add 2 pi to this, what do I get?
7 pi over 3.
Yep. Sorry, 7 pi over 3 when you add 2 pi. I'm going to add another 2 pi to this.
13 pi over 3.
Pardon?
13 pi over 3.
Someone said about taking away something.
Yeah, but I thought you keep going.
Take away what?
Like pi.
No, so for sine and cos, it repeats every 2 pi. So to begin with this question, there's basically been 2 answers for all of them so far. Like there was 2 answers here. In this one that we had down here for cos, there were 2 answers. Once you get those 2 answers, there's not going to be any other ones that you can get directly from like these top 2 formulae. After you've got those 2, if you want to find any more, you can keep adding 2 pi to this one or taking 2 pi away. And you can do the same to this one, keep adding 2 pi and taking 2 pi away. But so you always get 2 to start with for sine and cos, and then you can keep finding more from those 2. For tan, you just get 1 to start with, and all you're allowed to do for tan is either add pi or take pi away. So I've added on 2 pi. I'm going to add on another 2 pi, which is 13 pi over 3. That's still not bigger than 6 pi though, is it?
No.
So if I add on another 2 pi,
19 pi over 3.
I get 19 pi over 3. 19 over 3, is that bigger than 6 pi?
Yeah.
It is. So actually, I don't need that one. That one's gone a bit too far.
2 pi over 3 plus 2 pi is 8 pi over 3.
I'm only doing the red ones first.
Oh, so you do
I've done them in red to show I'm just adding 2 pi just to this one, okay?
So are they all valid values?
I haven't quite finished yet. So this one is valid, this one is valid, this one is valid, and this one is valid, because at the moment they're in between the 0 and 6 pi. Okay, and then there's going to be a further stage that you'll see in a second. So I'm not going to do any more with the red one. I'm now going to change my colour of the pen. What pen should I do? I'll do a black pen here. And I'm going to just look at this one, and I'm going to keep adding 2 pi to that one until it goes bigger than 6 pi, and that's where I'm going to stop. So if I add 2 pi to this one, I get 8 pi over 3. And again, 14 pi over 3. I'm adding on that 6 on the numerator each time. And if I add another one on, I would get 20 pi over 3. But the problem with that is 20 over 3 is bigger than 6. So this one is not going to be included. Okay? You might like to just add on 2 pi and then add on 2 pi. And then add on 2 pi and then add on 2 pi. You could do it that way if you prefer. Sometimes I prefer just doing it to the first one and then doing it to the second one. You may like to set up your writing where you say pi over 3 and then 2 pi over 3. And then just keep adding on 2 pi for each of them separately and having them in kind of 2 lines. I've got it in 1 line here. You might have preferred to do the red ones in 1 line and then the black ones in 1 line underneath. Okay? Whatever setup helps you to do this. So now I have got that 3 theta is equal to all of these solutions. But when you're trying to solve an equation, I'm not trying to find out what 3 theta is. I'm trying to find out what theta is. So to find out what theta is for all of these ones I've got written here, what do I need to do? Divide them by 3. Now, if they've all got 3's in the denominator and I'm dividing by 3, I get 9's. So I'm just going to write them now in order. So I would have pi over 9. That's that one there done. Then I would have 2 pi over 9. That's that one there done. Then I would have 7 pi over 9. That's that one there done. 8 pi over 9. That's that one there done. 13 pi over 9. That's that one. And 14 pi over 9. So I have now got for this one 1, 2, 3, 4, 5, 6 solutions. Why have I suddenly got 6 solutions rather than, in most of the previous questions, 2 solutions? It's because of the 3 theta, okay? When you think about a graph, sine theta does this kind of pattern, right? This is sine theta. What would sine 3 theta look like? No, not in the y, no. It would look like this. 1, 2, 3. So when we're talking about solutions to an equation, and this is all from the previous videos, normally it's like, where does it cross the graph? So here it's crossing it in 2 places. If I drew the same line, it's now crossing it in 1, 2, 3, 4, 5, 6 places. That's why we've got 6 solutions to this equation that we've got here. And I'm actually just going to show that by putting it on Desmos, okay? So I'm going to go to Desmos. Can someone just read out what the equation was again? Is it sine 3 theta equals root 3 over 2?
Yes.
Sine 3x. And then I'm going to do square root of root 3 over 2. Y equals. Okay, so guys, can I just talk to you about what we've actually just done here? So the red graph is sine 3x. Boys, what are you doing? Why are you talking now? I'm talking. So the red graph is sine 3x, or 3 theta, and we're only interested up to 2 pi. And so all the places where it crosses is where the solutions are. So you can see I have pi over 9, 2 pi over 9, 7 pi over 9, 8 pi over 9, 13 pi over 9, and 14 pi over 9. As soon as I get to this one, I get 19 pi over 9, and 19 over 9 is bigger than... No, it's not bigger than 6 pi, is it? Think. Bigger than 2 pi, because the question said that the range had to be less than 2 pi. So by adjusting the range here, it means that we're able to finish solving the equation that we have at this point, okay? If you weren't able to do chapter 10 during lockdown, I'm going to restrict the number of questions that I want you to answer, okay? I want you just to concentrate on these kinds of ones. I'm going to go on to some other bits now that are a bit harder. If you did the chapter 10 in lockdown, you should listen to them really carefully. If you didn't, just kind of listen to them and think, okay, this is maybe going to be a bit challenging until I've practiced the other bits. So this time we've now got some more sophisticated kinds of equations that we've got here. This one says I want to solve the equation 17 cos theta plus 2 sine squared theta equals 13 in the interval 0 to 2 pi. So clearly it's now a radians question because of this thing that we've got written at the end. But may I just point out, you still will get degrees questions in A2 maths, okay? Even though we're now learning radians, they still will put degrees questions in as well. It's not like the other one has now disappeared. Who remembers from beforehand how we can begin to solve this kind of equation that we've got here? Harmon?
Isn't the equation cos squared theta plus sine squared theta equals 1?
Good, very good. Sine squared theta plus cos squared theta equals 1. You said it the other way around, but it's the same. No, you're not wrong. It's just the way I remember it. I say sine squared plus cos squared is equal to 1. Anyone remember what this is called? Good, it's the Pythagorean identity because it actually comes from a triangle that looks like this. It comes from a triangle that looks like this. So this is called the Pythagorean identity. So the problem with this equation that we have right now is that we have a mixture of sine and cos. So we use the Pythagorean identity to translate it from a mixture into just one type. And so I'm going to make sine squared the subject. In fact, you really should memorize this, that sine squared is 1 minus cos squared theta. I'm then going to substitute that in place of sine squared theta. So I have 17 cos theta plus 2 1 minus cos squared theta is equal to 13. And now that equation is nice because it's all just in terms of cos. So that's 17 cos theta plus 2 minus 2 cos squared theta equals 13. What should I do? What kind of equation does this appear to be? It's a quadratic. It's like not like a traditional one. It's like what I call like a pseudo-quadratic. It's a quadratic in cos theta. So I'm going to put everything onto the right-hand side. So I get 2 cos squared theta minus 17 cos theta plus 11. Now, what I'm saying by it being a pseudo-quadratic is it really looks like 2x squared minus 17x plus 11. You can see how it means that. So you should now take your calculators and if you can solve that quadratic for me, and then you can tell me what the solutions should be for the quadratic. I'm just going to put brackets around that because it's like our kind of help. So what does the calculator say for the solutions, please? Has it got exact? It doesn't have exact answers.
No, it doesn't.
Okay, I want to check.
17 plus root 201 over 4.
Okay, just want to check I did the beginning bit right. 17 cos theta plus 2 1 minus cos squared theta
So
plus.
isn't that minus 11 by the way? Minus 17x minus 11.
No, I put everything all onto the right-hand side, so I added the 2 cos squared theta. So this tells me then that either x or cos theta, it tells me that cos theta is equal to, what was the version? I'm sorry, I just, not the exact one. Let's just have it as a decimal because it's going to be decimal answers.
7.79.
7.79 for one of them, and the other one?
0.706.
0.706. Give me a couple more numbers on that.
Oh, then I've just 0.7056.
Okay. Because you can. Good. So now this thing I want to talk about is this part of the equation that we've got here. The cosine graph looks like this, right? What are the values here and here? 1 and negative 1. So if I'm trying to say when is cos theta equal to 7 point something, well, never. Because cos theta is always between 1 and minus 1. So this one has no solutions. There are no solutions because cos theta is between minus 1 and 1. So there's no solutions for that. So all I need to do is find the solutions for this one that I have here. So I'm going to do the inverse cos of 0.7056, as many numbers as you can to make sure we don't lose any of them. Have you done that? Has anyone typed this in for me? Found out what the inverse cos of this is yet?
0.787.
0.787. Okay, so that's one of the solutions. How do I find the other solution for cosine? You can only, you could add 2 pi to it, but that's going to be pointless because it's going to go outside of the range. It's 2 pi minus this answer, okay? So if you can't remember these, you're going to have them in your notes. You've got 2 pi minus the one that the calculator gave you. So you're going to do 2 pi minus this. So you're going to literally just type in 2 pi minus 0.787, which is
5.496.
5.496. Okay, I'm going to just be safe and just do them both to 2 decimal places. So we have 0.79 and 5.50 are my solutions, and this is to 2 decimal places. Okay? What I'm going to do is show you on Desmos what this looks like. I know some of you will have been like, Sarah, I know how to do this. But I'm just wanting to make sure that everyone, you might not have looked at it for a while. You might not have had me actually teaching you this in person. So I'm going to type in the left-hand side, which is 17 cos x plus 2 sine squared x. So 17 cos x plus 2 sine squared x looks like this. And I'm going to find out when it was equal to 13. So I'm going to scroll out now. So the solutions are 0.787 and 5.496, which is what we had. And I'm not going to do these other ones that come up later on, because those are the ones, where do those other ones come from? Where do you think these other ones are going to be coming from? Good, adding 2 pi. So the point that I'm trying to make here is once you've got the first pair, there's always going to be repeating ones of those pairs. So the first pair is found by doing, for sine, you do pi minus the answer. For cos, you do 2 pi minus the answer. But with tan, you just keep adding pi or taking away pi each time, okay? So I've got one more down here. Let's see if we can do this one just a little bit faster. So again, we can tell we're going to have to use these identities at the top because there's a mixture of sine and cos. So I'm going to use this other one that says cos squared theta is 1 minus sine squared theta. And I'm going to substitute it into this part of the equation straight away. So that's 2, 1 minus sine squared x plus 1 equals 5 sine x. And a quick side note for any of you who may not have been able to see these videos before is when I write sine squared x with the little 2 there, that means sine x all squared. Okay, it's just a different way that we write it. Hannah, did you see this? This sine squared x is actually meaning sine x all squared. It's just the way it's written, okay? So I'm going to just expand. So that's 2 minus 2 sine squared x plus 1 equals 5 sine x. I'm going to put it all onto the right-hand side. So that's 2 sine squared x plus 5 sine x minus 3. What does the quadratic solver give us for sine x? Minus 3 and a half. Anything you should tell me? There are no solutions for the exact same reason as before. Sine is just like cos. Sine goes between minus 1 and 1. So there's no solutions for this bit. And then we're going to do all of this without a calculator now. So x is the inverse sine of a half. What angle of sine gives you a half? 30 degrees, which is pi over 6, okay? So if you couldn't do that, you could have written on your calculator inverse sine of a half and you would have got pi over 6. How else do you find the next one for sine? No, before that. You do pi minus this. You used to do it as 180 minus this for sine, but we're going to do pi minus this. What's pi minus the sixth pi?
5 over 6 pi.
Good, 5 over 6 pi. The range it wants for your answers are between 0 and 2 pi. So is there any point in adding 2 pi to either of these? No, there's no point in adding this. This one we got by doing pi minus pi over 6. So we have just these two answers here and here. I am going to put it on Desmos just to show you what this looks like visually, that it's only going to be crossing in those two places. So that's 2 cos squared x plus 1. And then the other one was just 5 sine x. So this time it's where do these two graphs cross each other in this region between 0 and 2 pi. So they crossed here at pi over 6 and here at 5 pi over 6. They don't cross anywhere else. That's actually what we did when we were solving this equation here.
Is the question still worth 6 marks?
I would say now that question would probably be 4 marks. Because you'd get 1 mark for using the identity. You'd get 1 mark for coming up with this correct thing here. You would then get 1 mark for this, for saying sine x was equal to a half. And then you'd get 1 mark for the answers. So I think it's a 4-mark question now. That's from an old exam. So we're going to probably work on just exercise 5e for most of today's lesson. If you haven't done the videos from beforehand, I'm going to want you to start from the beginning. And if you have, I'm going to direct you to some of the more challenging ones, okay?